The following data, plant height in centimeters, was obtained in an agricultural experiment with 3 different types of soils. We have loamy soil, clay soil, and sandy soil, and these are the plant height in cm. Does the soil type have any effect on the growth rate of the seedlings? Solution: this is a completely randomized design experiment. To analyze this data, we make use of a tool called ANOVA. That's analysis of variance. We present our table as shown here. The loamy, clay, and sandy soils are the treatment, as we call this treatment 1, treatment 2, and treatment 3, while these are the plant height. The total plant height under treatment 1 is 42, under treatment 2 is 51, and under treatment 3 is 34, and the grand total is 127. The number of observations under treatment 1 is 9, treatment 2 is 9, and treatment 3 is 9, and this will give us a total of 27 observations. Analysis of variance involves calculation of the sum of squares. We have to calculate the total sum of squares, the treatment sum of squares, and the error sum of squares. To do that, we have to first of all compute the correction factor, which is defined to be y dot dot squared all over n. Y dot dot is the grand total, while n is the total number of observations. This will be equal to 127 squared divided by 27, which is equal to 597.4. We now compute the sum of squares of total. The sum of squares of total, SST naught, is equal to sum as I goes from 1 to 9. That is, there are 9 observations under each treatment. J from 1 to 3. That is, there are 3 treatments we are comparing. Yij squared, that is the square of each observation, minus the correction factor. To compute this first term here, you have to square each observation: 4 squared, 7 squared, 3 squared, and so on till you get to 5 squared. You sum them. That will give you this sum. This is equal to 657. That is, this sum will give you 657 minus the correction factor 597.4. This is equal to 59.6. So the sum of squares of total is 59.6. Next, we compute the sum of squares for treatment. The treatment sum of squares, SST, is equal to 1 all over 9 sum j from 1 to 3 y dot j squared. Y dot j represents the treatment total. Then you square it minus the correction factor. We recall that the total for treatment 1 is 42, for treatment 2 is 51, for treatment 3 is 34. So we are going to square each of these, sum them, and then divide by 9. This will give us 42 squared plus 51 squared plus 34 squared all over 9 minus the correction factor. Simplifying this, we have 613.4 minus 597.4, and that will give us 16. Next is to compute the sum of squares of errors. The sum of squares of errors is SSE equal to SST naught minus SST. That is 59.6 minus 16, which is equal to 43.6. Having calculated all our sum of squares, we are now ready to present this in a table called ANOVA table. The ANOVA table is as shown below. This table consists of the column for source of variation, the column for degrees of freedom, column for sum of squares, column for mean square, and column for F statistic. We have a row for treatment. Treatment in this case are the salt type. We have a row for the error and for total. The degree of freedom for treatment, since there are 3 treatments we are comparing, so we subtract 1 from that. That is 3 minus 1 will give us 2. The degree of freedom for total is obtained first before that of error. There are 27 observations, so the degree of freedom for total will be 27 minus 1, and that will give us 26. To obtain the degree of freedom for error, you have to subtract that of treatment, which is 2, from 26, and that will give us 24. Then the sum of squares we computed are entered here. For treatment is 16, for error is 43.6, and for total is 59.6. To obtain the mean square is obtained by dividing the sum of squares by the corresponding degrees of freedom. So 16 divided by 2 will give us 8. That's the mean square for treatment. 43.6 divided by 24 will give us 1.74. That's the mean square for error. To compute the F statistics, we divide the mean square for treatment by the mean square for error. That is 8 divided by 1.74 will give you 4.6. Here we are testing the null hypothesis that the 3 soil types have the same effect on the growth rate of seedlings against the alternative that the 3 soil type does not have the same effect on the growth rate of seedlings. Here the critical value of our test statistics F at alpha equal to 5% and 2 numerator degrees of freedom, 24 denominator degrees of freedom, is F 0.05, 2 and 24 degrees of freedom. From the F table, this is obtained to be 3.40. Conclusion: the test is significant since the calculated F value, which is 4.6, is greater than the table value, which is 3.40. So we therefore conclude that the effect of the 3 soil types on the growth rate of seedlings are not all the same.